Once again, continuing with our algebra review, we're going to look at lines. We're going to go through this really quickly. I know you know a lot about lines. You've had a really good background in slope and all those kinds of things. So we're just going to breeze right through this really quickly. Remember that slope is rise over run. We can have a positively sloped line. We can have a negatively sloped line. So those things I know that you know. We can find the slope of a line given 2 points by taking the difference in their y-coordinates over the difference in their x-coordinates. Rise is vertical change, run is horizontal change. The slope of a vertical line is not defined because we have no slope. If there is vertical change, then there's no slope to the line whatsoever. The slope of a horizontal line, again, would be 0. So find the slope of the line that passes through these 2 points. I'm not really sure how many of these examples I'm actually going to do. Slope's usually some little m. We take the difference in the y values over the difference in the x values, and that is the slope. So this is a positively sloped line with a slope of 2/3. So the point slope form for the equation of line may be something I'm not sure how often you've worked with it, but it turns out in calculus we work with it quite a bit because it's really handy for us to perform calculus on. I want to just point out really quickly the point slope form for the equation of a line comes from rise over run. That's all we do is multiply both sides by, that should be x sub 1, x minus x1. That's really all in the world we're doing. There's no math magic here. So we have y minus y1, therefore has to equal the slope times x minus x1. And the point slope form is something that is really handy for us when it comes to our calculus work. So find the equation of the line through 1, -3 with slope 1/2. So again, I would quickly say it is y minus y1, which is -3, equals the slope times the quantity x minus x1. Very simple to do. And then it's very simple for us to move forward and use calculus on that. The slope-intercept form for the equation of a line is probably something you've used a lot. Y equals mx plus b, where m is the slope, b is the y-intercept. Not really sure I'm going to do any examples on that one. But again, here's all that's happening. It's just a manipulation on the slope-intercept form of the line, so, or point slope form of the line. So not difficult there. So I'm not really going to take time to do this example on slope-intercept because I think everybody has a really good handle on that. Vertical lines and horizontal lines, the one thing that I want you to know about those is that if we have a horizontal line, the x-coordinate is different anywhere along the line. There are infinitely many points that lie along this line, but the y-coordinate is the same everywhere. So when you see the equation of a line that is y equals -2, that means for every coordinate, every point on that line, the y-coordinate's -2. That has to tell you it is a horizontal line. Same for vertical lines. I find students, they're fine with horizontal lines, but for some reason when it comes to vertical lines and writing the equations of vertical lines, they get stumped. Well, if the x-coordinate to every point on this line is 3, and then there are infinitely many y-coordinates to the points on that line, then that is a horizontal line, x equals 3. So just make sure you're able to distinguish when you're asked to write the equation of a vertical or horizontal line that you could actually do that. The general equation for a line is it's not in the form that we're used to, which is y equals everything else, or y plus or minus a constant equals everything else. But given the general equation of a line, you can get those other forms very easily by just using algebra. Not a problem at all. So let's say we wanted to sketch the graph of this line, then we would either put it in point slope form, slope intercept form. It really wouldn't matter if we're sketching the graph. So what we would like to do with this, and I'll just work this really quickly, is we want to isolate y on one side of the equal sign by itself. So I'm going to move everything to do with x and the constant using good algebra on the right-hand side of the equal sign. Then I'm going to divide every term by -3. So this is 2/3 x minus 4. There's my slope. There's my y-intercept, which would make it very easy for me to graph. I'm not going to take the time to go ahead and graph it. But given the general equation of a line, it's very easy to come up with any other of the forms of those lines. Parallel lines, two non-vertical parallel lines are parallel if they have the same slope. Perpendicular lines are perpendicular to one another if their slopes are the negative reciprocal of one another. If I give you the slope of one line and ask you to find the slope of the perpendicular line, just take what I give you, put a negative in front of it, and flip it. Again, things that I know that you know. Word problems, modeling with linear equations, the rate of change, slope being the rate of change of things. This leads us directly into calculus, lots of rates of change in calculus. So when a line is used to model the relationship between two quantities, the slope of the line is the rate at which one of the quantities is changing with respect to the other. And if you're not in a habit of looking at what's going on your horizontal axis and looking at what's going on your vertical axis, develop that habit, because the horizontal axis, which is almost always, unless it's an upside down world for some reason, is almost always what's in charge. It is the independent variable. And then what's happening vertically along the y-axis is what is dependent on what's happening horizontally. So time, we can't do anything to manipulate time, but we can do the volume of gas. So this gives the amount of gas in the tank that is being filled at any given time. So the tank filled at 2 gallons per minute, the slope of the line is 2. All right. The slope between the indicated points, 6 gallons, 3 minutes, 2 gallons per minute. If the tank was drained at the rate of 0.03 gallons per minute, the slope would be negative, and it would be much more shallow. It wouldn't be such a steep slope as our positive slope of 2. Again, a really quick video. I didn't go into it really in depth. I know you're very comfortable with lines, but I do want to go ahead and get us talking about lines and rates of change, different forms of the lines, standard, slope-intercept, point slope, all those kinds of things. I just wanted to reintroduce them to you and get you thinking about them. So come to class, we'll do some homework on lines, and then we'll move forward with our parent functions.